this diagram on your website is really nice. Again, we're going to have a link to it. For anybody watching, if you're watching on YouTube, let's say, in the description below, there'll be a link. I'll get the team to put it right at the top there. So you'll be able to go in and actually walk through, but we'll do a visual as well. We've got this metering pump system overview, and it's a really nice graphic on your website. You can actually click onto it and bring up a description of the different parts.
Right.
I think you have it in front of you as well. Can we just walk through this, and then we'll bring it up on the screen as well?
Yeah, sure. So I mentioned before when you were asking about what does Blacoh do, that primarily it was built on pulsation dampening, and that's true. But Blacoh also offers a wide variety of other components that go into a metering pump system. So if you're looking at the diagram, you'll see that there are the pulsation dampener at the discharge and also the inlet stabilizer on the inlet side. But there's a bunch of other components in there that all go into making a metering pump system work, and Blacoh offers all of these things. So if we kind of walk through from the very beginning, the fluid's coming out of the tank and going towards the pump, of course, but because we have pulsing flow at that pump, and this is a metering pump, it's a piston pump essentially, because we have pulsing flow coming out of the pump, that means that we also have pulsing flow coming into the pump, right? Because the flow into and out of the pump has to be the same. So the inlet stabilizer is essentially a pulsation dampener that's specifically charged and designed to work on the inlet side. Lower pressure, less variation in pressure, but still a pulsing flow and a pulsing pressure. Blacoh provides these in a wide variety of sizes and materials, and can be used in any application where you have a positive displacement pump drawing fluid in.
Sorry, can I just jump in? Sorry, Chris. Sure. Can I just jump in for a sec? Can you just give me the base? Like, how does this actually work? There's basically an air pressure that, what does it do? Suppress the pressure when it's high and then eases off, like it automatically does it, or what is actually happening?
Okay, and you're pretty close. So what a pulsation dampener does, whether it's on the inlet or the discharge, is it's taking and giving energy to the system. So the pump is where the energy goes in, right? That's where you have your motor that's actually driving the fluid to increase pressure. But you also have the piping that the fluid is passing through that's being subjected to changes in pressure. Well, that pulsation dampener typically has a bladder inside of it that's charged with the air, nitrogen, or just regular shop air that is at lower pressure than the fluid, so that it compresses a little bit when the system is open and it's exposed to that pressure. And then as the pressure changes inside of that line, the bladder either compresses a little bit when the pressure is higher or expands a little bit when the pressure is lower to equalize that pressure. So as it's compressing, it's taking energy from the system. As it's expanding, it's giving energy to the system. But the net effect is that because you're allowing it some of that flexibility inside of the system, you reduce the variation in pressure in the piping. So that's what smooths out the flow and makes it a lot easier for the pumps to operate, because instead of seeing a change of pressure of maybe, let's say, 10 psi as the pump goes from a suction stroke to a discharge stroke, you're maybe seeing a change of only a couple of psi, because that dampener is softening that effect and taking and giving energy as needed.